Our Earth. A beautiful blue marble teeming with life. But was it always like this? Not at all. Our planet's climate story is a wild ride. It stretches across billions of years. Imagine a journey through time. We would see worlds that are hard to believe existed. Earth has faced fiery infernos. It has also endured icy deep freezes. These transformations are part of its grand cosmic evolution. Let us embark on this journey. Let's explore the most extreme climates our planet has ever known. Prepare to witness Earth as you've never seen it before. The very beginning was a time of incredible heat. This was the Hadean Eon. It started around 4.5 billion years ago. Earth had just formed. It was a chaotic, violent place. The young planet was still cooling down from its very creation. Picture this, a world covered not by oceans of water, but by oceans of molten rock. A glowing, red-hot sphere. Surface temperatures would have been thousands of degrees Celsius. This was hot enough to melt rock itself. No life could survive this. It was a truly primordial furnace. What would this early Earth have looked like? The sky above would have been dark and forbidding. It would be choked with dust, gases, and steam. Giant asteroids and comets constantly smashed into the surface. Each impact released enormous energy. This added even more heat to the molten planet. The moon, our constant companion, was much closer then. It would have loomed large in the sky. This was an alien, hostile landscape. It was a world still being forged in cosmic fire. A far cry from the home we know today. But slowly, ever so slowly, things began to change. Over hundreds of millions of years, Earth started to cool. The relentless bombardment from space gradually lessened. As the surface cooled, steam from volcanic eruptions condensed. This water began to form the very first oceans. These early oceans were still incredibly hot, but they were oceans nonetheless. This cooling was a critical step. It marked the end of the most extreme heat. It set the stage for an entirely new chapter in Earth's climate history. The planet was preparing for more changes. After its fiery birth and initial cooling, Earth's climate story was far from over. The planet continued to experience dramatic shifts in temperature. There were long periods when Earth became incredibly warm again. These were not the hellish conditions of the Hadean Eon. Instead, these were super greenhouse periods. Think of a global hothouse. Vast amounts of greenhouse gases like carbon dioxide were released into the atmosphere. These gases trapped the sun's heat. This made the entire planet much warmer than it is today. Let's step into these ancient, steamy worlds of the past. One such time was the Neoproterozoic super greenhouse. This occurred roughly between 650 and 750 million years ago. This was a period before the Great Snowball Earth events, which we'll visit later. During the super greenhouse phase, Earth experienced intense volcanic activity. Volcanoes are like planetary chimneys. They belched out enormous quantities of carbon dioxide. This CO2 built up in the atmosphere. It created a powerful greenhouse effect. Global average temperatures might have been 10 to 15 degrees Celsius warmer than our current global average. Imagine a world significantly hotter than any human has experienced. Much later in Earth's history, about 56 million years ago, another intense warming happened. Scientists call this the Paleocene-Eocene thermal maximum, or PTM for short. This was a truly remarkable event. Global temperatures soared by 5 to 8 degrees Celsius, and this happened very quickly in geological terms. The warming took place over just a few thousand years. Imagine a world where the poles were free of ice. Palm trees and crocodiles might have lived near the Arctic Circle. The entire planet was essentially a tropical paradise, or perhaps a sweltering hothouse depending on your preference. What caused the PETM? The primary trigger was a massive and rapid release of carbon into the atmosphere and oceans. This carbon could have come from several sources. Perhaps immense volcanic eruptions ignited coal beds. Or maybe warming oceans released frozen methane from the seafloor. Whatever the cause, the effect was profound. Ocean temperatures rose sharply. Deep ocean currents changed their patterns. Life on Earth had to adapt fast. Some species vanished forever. Others thrived, and new groups, like modern mammals, began to diversify. The PETM is a stark reminder. It shows how sensitive Earth's climate system is to greenhouse gases. Our planet has not only endured extreme heat, it has also plunged into unimaginable cold. There were times when Earth became so cold that it may have frozen over almost completely. Scientists call these chilling episodes snowball Earth events. Picture our familiar blue and green planet transformed. See it as a brilliant white sphere of ice and snow suspended in space. This is a shocking contrast to the fiery Hadean or the steamy PETM. These were not just ordinary ice ages. They were global deep freezes of an epic scale, testing the limits of life itself. The most well-known snowball Earth events occurred during the Neoproterozoic era. This was a long time ago, between about 720 and 635 million years in the past. Geologists have found evidence for at least 2, possibly 3, such major glaciations. During these times, it's thought that ice sheets stretched from the poles all the way to the tropics. The entire globe, or very nearly all of it, was encased in a thick layer of ice. Even the oceans near the equator, usually the warmest parts of our planet, might have frozen solid or been covered in thick sea ice. This was a profound climate crisis for the young Earth. What could have caused such a drastic and global freeze? Scientists believe a combination of factors was at play. One idea involves the breakup of an ancient supercontinent called Rodinia. As Rodinia fragmented, new coastlines were created. This could have increased rainfall and the weathering of rocks. This weathering process pulls carbon dioxide from the atmosphere. With less CO2, the greenhouse effect weakened. Earth began to cool. Once ice started to form, it reflected more sunlight back into space. This is called the ice albedo feedback. It made the Earth even colder, leading to a runaway freezing effect. What happened to life during these snowball Earth episodes? It was an incredibly challenging time for the simple life forms that existed then. These were mostly microscopic organisms, like bacteria and algae. How could they survive on a frozen planet? Some may have found refuge in small areas of open water. These oases could have existed near volcanic hot springs, which provided warmth from below. Or perhaps life clung on in places where the ice was thin enough for sunlight to penetrate. These tiny havens were crucial. When the ice eventually melted, after millions of years, life didn't just recover. It exploded in diversity, leading to more complex animals. The extreme cold of snowball Earth wasn't the planet's last encounter with ice. Much more recently, in terms of geological time, Earth experienced another significant cold period. This is known as the last glacial maximum, or LGM. It reached its peak around 20,000 years ago. This was a time when our own human ancestors were spreading across the globe. While the LGM was a serious ice age, it was not a full snowball Earth event. However, vast ice sheets, kilometers thick, covered large parts of North America and Eurasia. So much water was locked up in this ice that global sea levels dropped dramatically. They were about 120 meters, or nearly 400 feet, lower than they are today. How did the last glacial maximum compare to the more ancient snowball Earth events? The LGM was certainly very cold. Global average temperatures were about 5 to 6 degrees Celsius cooler than in the 20th century. But this was mild compared to a true snowball Earth. During those deep freezes, global average temperatures might have plummeted to a bone-chilling minus 40 or even minus 50 degrees Celsius. During the LGM, huge glaciers advanced and tundras spread. However, the tropics remained largely ice-free, and life continued to thrive in many regions. Snowball Earth, in contrast, was a much more complete and global glaciation. So, let's recap Earth's astonishing climate journey. Our planet began as a molten inferno, a Hadean world with surface temperatures exceeding 1,000 degrees Celsius. Later, it experienced super greenhouse periods. During the PETM, for instance, average global temperatures were perhaps 5 to 8 degrees Celsius hotter than they were before the Industrial Revolution. Then came the ultimate chills, the snowball Earth events. The planet became a glistening ice block, with possible global average temperatures around minus 50 degrees Celsius. Even the more recent last glacial maximum saw temperatures about 6 degrees Celsius cooler than today. These are colossal swings in planetary conditions. What can we learn from these incredible climate extremes of Earth's past? They powerfully demonstrate that our planet's climate is not static. It is an incredibly dynamic system. It can and has changed dramatically due to natural forces over geological timescales. Factors like the sun's output, the arrangement of continents, the patterns of ocean currents, massive volcanic eruptions, and the concentration of greenhouse gases in the atmosphere all play crucial roles. Understanding these past transformations helps us appreciate the complexity of our current climate. It reminds us that our world is in constant motion, a cosmic dance of change, forever evolving through time and space.